We are so excited to have you here with us. And today we are going to be talking about one of our fantastic webinar series, and in particular, how we design Wi-Fi in challenging environments. And I absolutely love this graphic. I used to play this game when I was younger. When we saw it, it just made put a big smile on my face. And we're really looking forward to talking to you about how we can, cover some of those really challenging environments using some particular antennas indeed to do that. So why don't we move along and then we can see who we've got on the show today. So Dale, perhaps you can introduce us all.
Yeah, absolutely. So today we have some special guests from AccelTex Solutions. We have Mr. Connor Burke, Product Manager and Engineer, and also Mr. Jason Rinaldi, Director of Sales. And then there's Matt on the Ekahau side. There's Matt and myself, Matt, Director of ECSC and Product Marketing, and myself, Dale, Sales Engineer for Americas. I think we're ready to get to the good stuff now, Matt.
Absolutely. So before we dive into it, what is a challenging environment? Well, when I think about this, I think about certain types of environments where we maybe need to think outside of the box, but how we're going to provide Wi-Fi coverage into these environments. So in particular, I think of things around, manufacturing plants, warehouses, universities, hospitals. They've all got their own unique challenges where we might not be able to just use the types of internal omnidirectional access points to provide coverage to these areas. We may want to leverage access points that actually support external antennas where we can, use something perhaps a little bit like this, where we want to focus the energy coming from the access point and the antenna in a certain direction. If you think about, warehouses where you're going to be wanting to cover really long aisles, you're not particularly going to want to just put an omni at one end of the aisle and hope it's going to cover that aisle. We're going to want to use external antennas that can provide beautiful coverage down those aisles to our client devices. There are also a lot of other challenges that we can overcome by using external antennas. And some of the things that come to my mind when we're thinking about these challenging environments around manufacturing plants and warehouses is that these type of environments can cause something to happen to our RF waves that are coming from the access points called reflections. And the way we can control this in a bit of a more controlled manner is again by using external antennas. There's also a lot of other factors that can consist of making an environment challenging around how we may or may not be able to install or mount our access points and our antennas, the heights, the restrictions, the angles that we want to focus them at, and particularly, how high the ceiling is. Once the ceiling height is over typically 4 or 5 meters, you're probably not going to want to use an omni internal directional access point to provide coverage to your client devices down at the ground. The other type of challenging environments that you want to leverage these external antennas for is perhaps when you've got large public venues where you're going to have a very dense amount of client devices in one certain area. So how you can provide coverage to those devices and control that is by using external antennas to focus at a certain area, a certain block of seats, and then you can control how many devices much better to connect to that access point or external antenna, rather than if you were using an omnidirectional access point where the coverage would just be kind of going out everywhere. You can't really control your cell sizes. So that being said, I'm going to hand over to Connor and Jason, who's going to talk us through their propositions around external antennas.
Yeah, thanks for that great introduction. Before we go into some of the more fun stuff where we get to go into specific use cases and deployments, I always like to do a quick review of the omnidirectionals and directional antennas, just to make sure that we're all on the same page before we move forward. So in general, you can kind of categorize antennas into either omnidirectional or directional. If you're looking at a pure theoretical omnidirectional antenna, that's a perfect omni. You'll have it almost like a sphere. You can imagine like a balloon or water balloon. And as you increase the gain on that antenna, you can imagine squashing that down. You can kind of see the elephant there squashing it down. And you can think of it as just making it flatten out and go wider. So as you increase the gain, you'll be able to cover more distance horizontally with your omni, but you'll start to lose some of that vertical. So you kind of have to see the trade-offs of that. But that is a pure theoretical dipole. Typically, what you're going to see more often is this GIF you see over here on the left side. And that's actually this antenna right here. It's not going to be a pure sphere. You're going to have different lobes coming out of it, but you can see that that main lobe is still your omnidirectional coverage that you're wanting to achieve. And then while we're on the topic, a lot of our antennas that we do that are omnis are more pure omnis where they go completely horizontal. They don't have what's called down tilt on them. When you start using the internal APs, a lot of those will have what's called a down tilt to them. And you can imagine that as if you're taking the pattern you see here on the left, folding it down a little bit and getting it to where it can cover a little bit more on the vertical plane. So just know that when you're using internal omnis, it's not always just purely horizontal to the face of that omni or to the face of that AP. And now going to directional antennas, this is where you can start to get some very unique propagation patterns and design around some very interesting environments. So the easiest one to understand for a directional antenna is a symmetrical beam width. So that means that your vertical and horizontal planes are going to have the same beam width, whether that's 30 by 30 degrees, like you see on the pattern on the left here, or you can make it wider or narrower as you go. And typically, as you increase the gain, you're going to narrow down that beam width. So like this 30 by 30 you see here on the left, that's a 13 dBi antenna. That's a pretty high gain antenna. We typically see this one used in those higher ceilings for large public venues, or anywhere else where you have a longer shot that you need to be able to reach your destination. And you can imagine basically in that high gain to narrow beam width and low gain to wide beam width almost as a mag light. So if you had a flashlight and you turned it to narrow down that beam, you can imagine that beam getting brighter and more focused. And if you were to turn it back, it widens out, but you're not going to have as intense of a light. So you can kind of imagine it as a flashlight in the most general sense for symmetrical beam widths. There's also what's called asymmetrical beam widths for directional antennas. And that's where you start getting into the antennas like we design for warehouses, like this guy right here. So this one has 120-degree beam width on its vertical, so very long, but only 15-degree beam width on its horizontal. So what that allows you to do is design specifically for warehouse aisles to where it goes, your propagation goes up and down the aisle without bleeding over into adjacent aisles. And now we're going to ask a quick poll question to get some fun data from y'all.
Okay, so now for our first poll question, how often do you use external antennas in your Wi-Fi designs? A, never, B, rarely, C, regularly, or D, always?
Yeah, I'm just going to launch the poll question now. So hopefully you can see that coming up now and cast your vote. So it'll be interesting to find out how sorry, I feel really bad. I didn't launch the poll question in time and now everyone's using the chat to answer. So please use the actual poll question that we've launched. I'm sorry, I was a bit slow there. I was reading the Q&A. There's lots of great questions coming in right now. So there's one in there in particular that I think we could probably talk to in a few moments time once we've just given everyone a chance to finish the submissions for the polls. And what I'll do now is I'll just end the poll and share the results. So really interesting about how to find out how often you're using external antennas in your designs. And we can see that a really big portion had either said never or rarely. So over half of the people on the webinar today don't use external antennas. I wonder if after the webinar, you've seen some of the benefits of using external antennas that you might decide to start using them in your designs moving forward. Okay, well, I think that's good enough to stop sharing the results here. And Connor, I saw a question that came into the Q&A, in particular about what you was talking around, having the external antennas when they're installed up quite high and they've got, high gain and they can be focused down like a really long aisle so they can cover a really long aisle. One of the questions that came into the Q&A is that how does the client device talk back to the antenna? Because the antenna's got obviously a big and large antenna can cover that aisle, but then how does it work in going back in the other direction?
Yeah, so obviously you do have your transmit disparity between your client device and your AP. And that does come into effect, but typically in the distances you see for a warehouse where at most, if you have an extremely long aisle, those are going to be around 600 feet. And you would typically at that point start using 2 of the warehouse antennas or multiple of other antennas. So really when you're just using like a single antenna to cover a longer aisle length, it's anywhere between 300 and 400 feet on average. And at those distances, there really isn't an issue with the client being able to talk back to the AP. You usually start seeing that at the longer distances of over 600 feet. So at the distances that you're using here that aren't point-to-point shots, that isn't as much of an issue.
Great, thank you, Connor.
And now we'll hand it over to Jason.
Thank you. Appreciate it. Thanks, Connor. Thanks, Matt, for the nice introduction. Appreciate you guys having us on. Always love discussing this topic as an antenna manufacturer. So I'm going to go through kind of why you would use external antennas. You know, what are some of the location considerations, mounting considerations, and then some of the other things that you want to think about. So first things first is why external antennas. Quite a few reasons listed here, as you can see. You know, from a precision standpoint, if you want to create, you know, cells for high density deployments with minimal overlaps, you can kind of create seamless roaming. Matt kind of mentioned in the opening about manufacturing plants and places like that, where you may have some reflection, whether it's off of machinery or off of some of the aisles or anything metal that might be out there. Some other projects we've worked on, for example, like a cell phone repair facility, right, where they've got tables kind of right next to each other and they need a really focused cell on each table. So that's, you know, a few reasons there. Streamlining your design. Now, some of the AP manufacturers may want to plug their ears right here. But like a warehouse aisle would be a great example, right? And Connor just showed our warehouse antenna, where you can really reduce the count within an aisle, where as Matt mentioned, you may right now be using omnis throughout the aisle, where you may have 3 APs with omnis on it, kind of blasting the coverage out. Where if you used one of our warehouse antennas, you could really just have 1 AP in the middle of the aisle, and with an antenna obviously connected to it, and you really get coverage directly down the aisle and really reduce the number of APs. Aesthetics is certainly a concern, right? Another thing is interference, right? You can reduce co-channel interference. You may have an adjacent building that's blasting RF out because they don't really care about what you're doing. So that's something to consider as well. Again, bounce off of things as well. Added physical security, we see that quite a bit. Now, whether that's physically hiding the AP behind a wall or behind a ceiling, so somebody can't go in there and plug in something or tamper with the device. You may need to have it in a metal enclosure or even an explosion-proof enclosure where you need to run the antenna out from where the AP is mounted. And then, you know, actual physical security. So we see a lot of times in high school gyms and schools where kids are using these things as target practice. So you may want to get the AP and the antenna higher up to make it a harder shot for them. Some of them still may figure out a way to hit it, but it's certainly something to think about in warehouse environments and manufacturing facilities. You know, you have forklifts and waves driving around. You want to keep obviously things from hitting them and knocking them off. And then certainly in high density areas. So think about stadiums and large lecture halls where you're really trying to focus that coverage area and steer clients to a specific AP. Convention centers are another place where we see this type of deployment as well. And then certainly when you have a long distance from the antenna to the coverage zone. Now that could be outdoors, right? Maybe you're at a college campus and you're trying to cover a big open area outside, but the only place you can put the AP is on the 2nd or 3rd story. So you'll want a directional antenna to really focus that RF energy down to the coverage zone. The next one we're going to talk about is, you know, what's the best location for an external antenna and some of the things you want to consider there. Obviously, your coverage requirements, that always depends, right? You may require redundancy where you need you know, secondary or even tertiary coverage. You want to factor in the client devices. So maybe a scanner in a warehouse, they have different RSSI needs. And so you may have a scanner that requires neg 70. You may have one that requires neg 65. And we're starting to see some of the scanners requiring more and more. So it's certainly something to think about there. Always recommend a site survey, right? As you guys know, when you get into an environment, the things like metal and what the walls are made of always make a big difference. So you want to make sure that you do a site survey. The Ekahau AI Pro tool is obviously fantastic. Connor's going to do a really good demo of that later on. Again, I mentioned a little bit earlier, the AP placement. You may not have a lot of places to mount this. You may have, you know, 50, 60 foot ceilings or vaulted ceilings. So a lot of times you'll need an external antenna to get that RF coverage down to the coverage area. And then aesthetics, as you guys know, it's more and more of a concern these days, whether it's a historical building, it's a hotel, it's a theme park. So again, these antennas can be a lot smaller than the APs, much more easily hidden. And so that's another consideration to take when you're thinking about external antennas.
And I think we might even have a game later on in the show about
Yes.
trying to find some of your access points and antennas that you've done a very good job of hiding.
We take pride in that. There's a lot of people, as you guys know, a lot more people outside of engineering are not wanting to see these things, right? You get an architect that's working on a historical building and they don't want to see these access points and APs. So we've come up with some creative ways to hide them, and we'll do a quick little game here at the end to show you that. So the next thing to consider is how the antenna is going to be mounted. And you may not think about this right off the bat, but obviously there's a lot of different ways to do it, right? The ceiling mount, a wall mount, a pole mount, I-beam, whether the antenna needs to articulate. So you want to think about, do you want it flush mounted into a ceiling, or do you need the ability to articulate? What is the wall made of? What's the diameter of the pole? Things like that. How big is the I-beam, and how are you going to attach it? Other things to consider, like on this slide, do you want to co-locate the AP and the antenna, meaning having it on the same mount so you have a single attach point, which obviously makes it a lot faster and easier to deploy, kind of reducing man hours. So you'll see, across the top here, you see some of our co-location mounts. On the wall mounts, maybe on a corner as well, right? Or you may have an enclosure with an antenna underneath. So again, trying to consider all of those things and whether you have the right mounting equipment. And it's not something that you want to do when you're out in the field, right? You don't want to try to figure this out while you're mounting it. So it's something that you want to consider, ahead of time. So this is, something that's very important to consider. Now, other considerations are the antenna leads, the number of leads, the connector types. And as it says here on the slide, the first thing to remember is there's nothing common about it. The only sort of commonality is most of the outdoor access points have end style connectors. But other than that, the Mists of the world, Aruba, Cambium have RPSMA, Cisco and Meraki are RPTNC. The newer Cisco access points, the 9120s, 9130s have a DART connector. The new AP45 coming out with Mist has a multi-port connector. And you always want to look at the number of connections on the AP versus the number of leads on the antenna and make sure that matches up. Some of the older ones have 3 leads. 4 leads were pretty common, then moved to 6, and now we're at 8 and even 10 leads. So again, these are all things that you want to look at before you deploy. You don't want to get out in the field and have these questions in your head and maybe have had the wrong antenna or the wrong connector type, because then obviously it's going to slow down your install. Now, the other thing, and some are easier than others, but know where you can find this information, your resources. It's typically found on the hardware spec pages of any of the major access point manufacturers. Some make it harder to find than others, but you can see in these examples here, they're typically showing, the number of connectors, the type of connector. Again, it can vary between the different manufacturers, but you're typically finding that on the hardware spec pages. So something to look at, something we live and breathe every day when we're trying to pick the right antennas for our customers. So something to certainly consider there as well.
All right, Matt, so time to fire up the next webinar poll question. So this question is, what do you find most challenging in your environment? A, number of devices in the area. B, physical environment. C, AP placement. Or D, aesthetics. So just please use the poll and let's see the results momentarily.
Yeah, thanks for prompting me there, Dale. Again, I was getting caught up reading in the Q&A. Lots of great questions coming in today in the chat. Is really good to see so many questions and people having a good conversation in the chat. And I just wanted to come back to something that Jason said earlier around using the external antennas when it comes to things around that aesthetics concerns. I've been to so many environments where, like you said, the architects are almost offended if they see or show an access point on display. And the amount of times that we've had to come up with a clever solution to put the access point above the ceiling and then use a low discrete flat antennas like some of the ones that you have to really kind of not have it as so on show and display, but also provide good coverage and connectivity to the clients, but then not as be as big of an aesthetics concern. And what I'm going to do now is I'll just end the poll and share the results so we can take a look at it all together. And the thing that everyone seemed to find the most challenging in your environments is the actual physical environment. So what is going on in the environment? I mean, yeah, that is a massive challenge, especially when you're working in these types of environments that we mentioned earlier around manufacturing or warehouses when you've got racking aisles with constantly changing inventory, perhaps even just going back to a typical office space where your physical environment might change quite a lot by the amount of staff that you have in. Perhaps you put on events and have sometimes you have a large congregation of people in certain areas, and then sometimes you don't. So the physical environment, yeah, I think I agree with everyone in the audience. I would say that would be probably the biggest challenge. So I'm going to stop sharing now, and I think we have another poll straight from the poll. Okay.
Yes, we do. So yeah, this question is, which environment do you think is the most challenging? A, warehouse, B, university, C, hospital, D, multi-floor office building, or E, other. And you can tell us in the chat if other.
Oh,
I'd be
okay.
very interested to see those other ones. Yeah.
Well, yeah, I see a theme park in there.
Yeah.
Super yachts. Wow.
Airports, yeah. A few aircraft hangars, okay. Stadiums.
RV parks. That's a good one. We have an RV, and every time we're out there, we struggle with the Wi-Fi, to say the least.
Yeah, okay. Well, I'm going to end the poll and share the results, but what was really interesting is seeing some of the environments that people were putting in the chat. So, you know, stadiums and the aircraft hangars, cruise ships, I can imagine they are pretty challenging indeed. I would love to hear more about some of the stories that you've got from designing in those environments. But the one that got the most votes just slightly on the poll was warehouses. Yes, I definitely agree, these can be very, very challenging. Okay, well, I will stop sharing and head back over to
And guys, I do want to interject with a question around warehouses. It seems to be an upvoted question. So in a warehouse with multi-level pick mods and conveyors, how do you plan for refraction off of all the steel and machinery? What's I know that Jason, you mentioned sometimes down the middle of an aisle, but what can you say around this?
So for that specifically, there's obviously kind of some general rules that you can kind of tell where the reflection is going to go, but that's where using a tool like the Sidekick V2 is really important, because you can have a general idea of how it's going to react in that environment, but everyone is going to be different. There's not really any general like rules to follow that truly tell you how it's going to react. So going into your site, actively surveying it and seeing how it's doing right now, that's going to give you the best idea of how to actually design around your environment. So, I mean, doing the physical survey is really the only way to be able to design properly after you have those results.
Yeah, I completely agree, Connor. And there is a feature in Ekahau AI Pro as well that does allow you, when you are doing your designs, to account for reflections and diffractions as well. So it's a option that you may have overlooked or not seen in the app. So when you're designing for these types of challenging environments, it's obviously, of course, really important to go on site to collect that data with your sidekicks. But also when you are doing your designs, your simulation in Ekahau AI Pro, when you have the heat map visualization, if you go to the options and then turn it up to max, it will enable the reflections and diffractions. So it takes that into consideration as well. So when you're doing your planning, you can get an idea of potentially what that is going to look like in your environment as well.
Great question, though.
Yeah, definitely. All right.
So now let's get into some of the more fun stuff where we go into the actual use cases, some predictives, and even some great surveys that we were able to get. So we were looking here at some manufacturing warehouses, which is clearly a hot topic right now with this group, as well as some large public venues of both auditoriums and convention halls and some stadiums. So one thing that I always like to point out, and Matt had alluded to this earlier, is the moving inventory that you have on your shelves and the difference that can make. So these are obviously some pretty old surveys, but I think they still show the point very well. This was using just a 810 patch that we have, which is 45 by 80 degrees on the beam width. So just kind of a general asymmetric, kind of wider patch. But the thing I always like to point out here is that you can really tell the difference. We did a survey when they had full inventory on the shelves. And for reference, this is a large pet food supplier. So this is full of wet food and dry dog food and cat food on these shelves. So really high attenuating items. And you can really see it here as you do the survey when the shelves are full. You have pretty minimal bleed over into those adjacent aisles. But as soon as you remove it, and especially on 2.4, with that longer wavelength, it really starts to bleed into the other aisles as you remove inventory from the shelves. It still occurs on the 5 gigahertz, but it's not as dramatic. It's roughly similar, but you can definitely tell as you remove inventory from the shelves, you're going to see a lot more bleed through into those adjacent aisles. And that's going to change your entire RF environment on a day-to-day basis, just depending on what you have on the shelves at the time. And here are just some warehouse mounts that they used in this environment. They specifically use this one with that antenna. Okay, now we're going to go into some live demos. So here I just have a live demo of a really basic warehouse structure. And in the middle here, I have an internal Omni placed at the same height as these, and that's at 50 feet. It's a high ceiling warehouse, which is what we're kind of designing around, roughly 300-foot aisle lengths. And these are kind of the general design methodologies that we see people use in their warehouse environments. They either take an AP, shoot it down the entire aisle, have one on the adjacent or on the opposing side, shooting back the other way in the adjacent aisle, and just kind of alternate that back and forth. And that does work, and we'll go into that in a little bit. The other option we see a lot of the time, which people are starting to move away from, which is good because they usually see a lot better results, is just hanging their internal Omnis. And this can work depending on your ceiling height and what actually you're storing on your racks, or if you even have racks, if it's an open palletized area. But specifically here, we're looking at a racked warehouse environment. And then on the right here, we have antennas being mounted in the center of the aisle with its beam widths going up and down the length of it. And typically, this is what we recommend because we see the best results, but we'll start going through all these more in depth. So going back to this one on the left here, where you're shooting down the aisle, you do see good results here. The main issue that I have with it, where I kind of deter people, is if you were to say grab, we'll say a door, because that's roughly your body, your water, what is water, and throw that in the middle. If you're just walking down, you're going to see a significant decrease in signal coverage at the end of the aisle. So as you have multiple pickers or multiple people walking through the aisle, or especially if you have any forklifts going through the aisle, you're going to see significant decrease in your coverage as those guys are moving up and down the aisles at the end of the aisle. So it does work if you have just one or two people in your warehouse, but if it's a large warehouse with lots of moving pieces, your environment's not going to be as consistent or as stable as it could be. Whereas if you were to come over here to doing a center warehouse rack, it has less of an impact overall because you're higher up, it's going to the end of the aisles. So you're not going to see as much of an impact as you walk through the aisle compared to the guys on the other side of the aisle. And then going to the center mounted Omni. Come on, delete. So you can see here, obviously, it's covering a lot less distance, and it's mounted at the same height as these other APs. They're all at 50 feet and all at the same power. But you're not getting nearly as much coverage in your entire aisle, and your signal strength is a fair amount less. Even at the strongest point here, we're seeing 64. So you'd require multiple APs per aisle if you're wanting to be able to mount them at the top of your warehouse so that you're not having to worry about any forklifts or pickers driving by, knocking them off, and causing damage to your actual network. Now, if you were to take it and say, or I can change here, drop it down to a more reasonable 20 feet, which is where you would typically see Omnis, you see better coverage. It's still not covering as far because that's not what it is designed to do. And now you start seeing bleed over into the adjacent aisles. You can see that these adjacent aisles are starting to see the signal coverage from this AP. And you can start running into a lot of issues there to where your devices won't roam correctly if you have it end of aisle AP, and it's still hearing the other AP that it was previously associated with, still very strong. It's not going to roam correctly as you move to that next aisle. Or if you're just walking down the aisle purely down the middle, it'll start hearing that. You'll get co-channel interference if you're using 2.4 on any of your scanners, or it could accidentally roam to that other AP, and then you just start having a less optimal network than you could if you had designed around using a more specifically designed antenna for that area. So that was just a kind of general basic warehouse design that we see typically. But now we're going to get into some really fun stuff, because we were able to go out and test with a Juniper Mist AP45E WW, the worldwide edition of it, that has 6 gigahertz enabled with external antennas. So we got some great results from this. They're really interesting. I'm glad to share them with y'all. Y'all be the first ones actually to see these results. So I'm interested to see what everyone thinks in the comments as well. So just some background information on the area we're in. It was a palletized warehouse, 300-foot aisle lengths. The aisles were a little bit wider than your typical aisle here. You can kind of see that displayed here. And we're mounting at about 35 feet with this extended pole mast. And then we'll go into the actual survey.
This is very exciting. Thank you so much for sharing this with us, AccelTex guys, and the people on the webinar today. So you were able to collect measured survey data on some 6 gigahertz external antennas with a 6 gigahertz capable AP. I guess you must have been using the Ekahau Psychic 2 then.
Yes, sir. Yeah, we got to be able to use the Ekahau. We had a couple Psychic V2s actually running this, and they all were doing a fantastic job. And it's really the only option you have right now to be able to run around and see 6 gigahertz in the actual field. So it was extremely educational for us to be able to use them. And we're grateful that you all made such a great device to show this off. So for this here, this was specifically that same aisle, but we were mounting the AP at the center of the aisle. And also, in case y'all weren't aware, as of yesterday, or 2 days ago, there was an update to Ekahau that was input the AP45E, as well as all the antennas that have recently come out with it with us. So that was a great addition, and we're excited to let people be able to do predictive modeling with them now. So that's great. So this here was our 8 dBi warehouse antenna, and it was mounted in the center of the aisle. And I'm also going to turn this off after though, just putting it there for y'all. It's all right. Should have done this beforehand. There we go. Oh, now it's doing 2.4. Oh, that was the actual. So that's where the AP was mounted for this specific survey, and it had the antenna pointed straight down. So if we were to go back here to this and then look here, so it was the same setup, but your AP was facing straight, or the antenna was facing straight down for this survey in the middle of the aisle, kind of how we were discussing earlier with the center mounted warehouse aisles on those antennas. And then I'll delete that because it's messing around. So here's just your typical 5 gigahertz survey. This is what we've been able to know and love. You can see that it's covering the entire lengths of the aisles. And this is one aisle, by the way. This is just me going down the left-hand side of the aisle and the right-hand side of the aisle, because they were wider aisles. So you can almost imagine this as one aisle. It did have a little bit of bleed over, but these were open palletized areas. The racking wasn't stacked too high. So a little bleed over is expected. But you can see that it's covering the full length of your 300-foot aisle without any issue. You're getting good coverage, good signal strength throughout all of it. And it was great. What was interesting is that then we looked at the 6 gigahertz results for this. And for this specific antenna, it's the same gain. It's 8 dBi in both 245 and 6, as well as the same beam width. So it's 25 by 110 degrees on the beam width for this 8 dBi warehouse antenna. So exact same, in theory, propagation pattern, besides the 6 gigahertz frequency, that's going to make it go a little bit less because it's going to have more free space loss. And you can see that here very clearly. It doesn't reach all the way to the end of the aisle with that exact same propagation as the 5 gigahertz, but you get about 250 degrees of coverage, or sorry, 250 feet of coverage down your aisles to neg 67. So, I mean, it's still covering the fair amount of your aisle. It's doing a great job of being able to roughly match what you're trying to cover with 5 gigahertz. So obviously from this, we can tell it's not going to be a true 1-for-1 swap if you are starting to plan your warehouse designs with 6 gigahertz. which most people aren't right now until we start getting more autonomous ground vehicles in that require 6 gigahertz. There's not too many needs for it in a warehouse specifically. But in general, if you're designing with 6 gigahertz, it's not going to be that one-for-one swap, which is kind of what we were seeing with the internal models that were using LPI. But now we're seeing even with external antennas at a higher gain than the internal models, that is still going to be the case. And then similarly, we'll look at the other option that we saw on the initial run through of a basic warehouse design, to where we're looking at if a antenna was mounted at the end of the aisle. So we'll go back to 5 gigahertz first. So this is the 8-10-10 of our antennas for the 45E. And this antenna has a 45 degree by 45 degree on the 6 gigahertz and 50 by 50 on the 5 gigahertz. So it's a little bit wider. It's a symmetrical beam width. And they're shooting it down from the end of the aisle. So it's mounted right here. And that's actually the photo we saw, where it's at a 45 degree angle from the end of the aisle facing down it. So you get your adjacent coverage into the adjacent aisles, which these guys actually specifically planned for. They expect on their open palletized areas to have a secondary coverage in the adjacent aisles from the AP on the opposing side. That's something they designed with. But you can see on your primary aisle that you're actually trying to cover, you get the full 300-foot length coverage without any issue. And that's fantastic. And you can see as well on 6 gigahertz, it's about the same. So again, it's a little bit less than that free space loss at the same gain, the 10 dBi. It has less bleed over because it's having more free space loss, as well as being slightly narrower on the beam widths, but you're still covering down the 300 feet since you're mounted to the end of the aisle. So you get a little bit more coverage than you were on just the 8 dBi at the same power transmit level. But you're able to cover the full length of the aisle, but is losing more gain or more RSSI value to the adjacent aisle. So for these guys specifically, not going to be able to plan around that, but it is still great that if you're just trying to get a single coverage down your aisle, that you can still design around that if that's how you and your team design. So that was the quick run through of the 6 gigahertz surveys that we did in this warehouse. And I'm sure there'll be lots of questions about that one, and we can answer all those at the Q&A at the end. But I'm, again, very happy that I was able to share that with you all here on the Ekahau webinar. And again, thankful to Ekahau for making a great tool that let us be able to actually see this. All right, so now let's move over to some other use cases where external antennas can be a great help. Specifically here, we're going to be looking at a convention center. So this was a large event that had around 2,000 or 3,000 attendees, all stacked in a main hall of a convention center, where they were all using their laptops throughout the whole event, and were needing consistent coverage. So in this one specifically, they were mounting along these rafters. You can see them here, as well as using, we call it our quad mount, that allows you to put 4 APs and 4 antennas on a single mount. This one actually also has a switch in there, interestingly enough, to cover more of the open space areas where you're not needing these exact individual cells of coverage. But so here's the predictive design that they were able to do for this. And you can see the individual coverage cells that they were using for this design. So every one of these is this coverage pattern. And you can kind of see here how densely populated all these seats are. So every one of these squares is a seat that was being used during this event, and they were all populated. It was a very high attendance event. It was extremely cool to be able to see this in real time and have this much density in one location.
And just to interject slightly quickly, Connor, is that if you're looking at the heat map and thinking, oh, I don't quite recognize that heat map visualization from Ekahau, well, you can actually change the color of the visualization inside of Ekahau. So the default color shows green signal being really strong signal, going to, you know, kind of a weaker signal, and then you can change those visualization legends to perhaps if you know, maybe wanted to see it like Connor had in his slides, where it was going from when you're close to the access point, it's a hot, strong signal. And as you move further away from the access point, it becomes kind of like a blue, colder signal. You can totally choose and play around and configure whatever kind of heat map visualization your preference is. So just wanted to call that out in case anyone was getting a bit concerned, thinking, oh, why is the signal so looking so different here?
To that point, that was actually a custom one, so that you can also adjust your sliders, obviously, and change it individually. You don't have to use the preset one. So the end user that made this has their own custom one that they like to design with. So that's why you wouldn't find this one just in the default patterns. But I actually think it's a pretty nice color outlook to be able to see it on the hot being red. But yeah, so that was their predictive design. And then during the actual event, during the keynote of it, they were able to take a survey through down one of the aisles. And you can see here that they walked up and down the same aisle here. And it was very close to what we were seeing in the predictive modeling. So it did a great job of accurately predicting what you were going to see. And it caused these really tight cells of coverage that they were looking for. And it did end up being that way. So they had a lot of high density, very low client to AP association. So everybody had great throughput. They had great performance. There wasn't any issues, as well as they were specifically for this one only using 5 gigahertz. But as you can tell on the previous slide, that's a lot of APs. You would actually run into co-channel interference at that point. But with how tight the cells were, they weren't seeing any issues with that. So the interference was overall very low for the density that they were getting in for this event. And now we'll move on to the stadiums event. So this one specifically was for a basketball arena in the NBA. And this one we actually did a lot of really cool designs for, to where we were able to hide some of the antennas and multiple antennas along with their AP inside section numbers and handrails at the entrance to your sections. So beyond just having to worry about actually covering your clients in the stadium, they also had to worry about your aesthetic issues. And this is where our enclosures can come into play to really hide everything and make it to where you're going to have great performance and great aesthetics. So that one was a really fun deployment we did. And that might be a hint for later if y'all remember that one on the game. But now we're going to go just into another quick demo showing off the stadium. So this here is just a real simplified stadium. There we go. Just a typical basketball stadium surrounded by seats. Nothing too out of the ordinary. A lot of you may see this. So if you were to look here specifically in the middle, I have an Omni place. So this Omni is at the same height as these higher gain APs or antennas. And that's at 100 feet. So it's a high ceiling basketball court or football arena, depending on what you're designing for. So right now I have the power cranked up to where you can hear it everywhere. So obviously you're like, oh, great, I can hear everywhere. But now you have a lot of issues because so can the other APs and so can every client in that stadium. So you're going to run into issues where clients don't roam for one, but you're also going to have extremely high co-channel interference if you start placing 1 million internal Omnis all over the place. That are at a high enough transmit power to be able to reach the floor. And if you try to go, okay, well, I'll lower my transmit power by 4 dB at that same height. Well, now you can't hear it anywhere. So now you run into the option of, well, I can either crank it to where everyone hears it, or I can turn it down to where no one hears it. So if you're trying to get coverage to your actual court or field, it's really difficult to do with internal Omnis. That being said, it can be done for the actual stands. And we've seen plenty of great designs where that has gone well, where they do underseat enclosures and have your Omni placed there, and you can get really good coverage there. But there's more than one way to design a network. So another way that we see a lot is over the head coverage. So here we have our network that has our 60 by 60 degree 7 dBi antenna. So just a simple symmetrical beam width to cover one sector or one section number of seats. And you can create nice isolated cells to where each one covers an individual section without too much issue. So you can cover these individual section numbers that you're trying to get. And I also always like showing off the 3D propagation patterns. So we actually just generated these using MATLAB and our radiation patterns. And you can see here, this is a pretty wide 60 by 60 degree, like I said, antenna. And then in the middle here, we have our 30 by 30 degree antenna, the same one that you saw in the 3D moving GIF from earlier. So these guys are covering down here. And even at that 100-foot ceiling height, you're still getting coverage down to your stadium floor, even at a lower transmit level. And what's good about all this, where you have these very nice isolated shells that have clear rounding off points to where they're not bleeding out extremely far, is that it's real easy to design your network as far as channel utilization. So say, for instance, here, there's a 161 and there's a 161. Ooh, didn't hold control. You can tell that those don't really have any overlap, but it does to the adjacent APs. So you won't have as high of interference from APs on the same channel, but you'll still have plenty of secondary and even tertiary signals that are using different channels. And the same goes for these APs that are using the 60 by 60. If I can find a 53. It's not one close. Yeah, so either way, you kind of get the idea that it's showing you that you can design a network with nice isolated cells that are easy to control, easy to manage, and easy to design with. All right, and now I think it's time for a fun game.
Yes, we love this game. This is probably one of the best ones that we've done in a theme park. Again, try to spot the wireless. There's a Meraki AP out there with some pipe bomb antennas on it. Very hidden. This one was great. It's one of my favorites.
Yeah, let us know in the chat. Yeah, put it in the chat where you think the AP is, and the antennas.
Yeah, I'm seeing a lot of good answers.
Yeah.
And yeah, a lot of you're right. It's right there in the middle. But I mean, if you're not looking for it, that's pretty good.
You know what? I spotted the access points, but Jason, until you said about the dipole antennas, I didn't even notice them myself.
Yeah.
So until you said them, I completely missed them. So well done to anyone in the chat that spotted them. You got a better eye than me, or maybe well done to the AccelTex guys and girls for hiding it so well. I could see the AP, but yeah, that's just blown my mind. I've only just noticed the dipole antennas.
Good. That's the intent. Yeah, we have a very creative team, so it's good. So this next one, yeah, is got a full panel antenna. This might be somewhere like a cell phone repair shop where they might have a drop ceiling and kind of want to hide it. This one should be easier to spot, but still pretty unique, and the naked eye you wouldn't see it.
Mm-hmm. Someone did point out, yeah, the logo may be a giveaway.
Yeah, I was thinking that too, but you're not looking.
Start making ceiling tiles. That way it blends in better. You don't know if it's a ceiling tile or an antenna at that point.
Yeah, we've actually done it where we've skinned, an antenna and an access point to match that ceiling tile kind of popcorn look, and it blends in really well. So there you go. That's a pretty good one.
Yeah. Someone also made a good point. It's the only one that's not sagging because it's sturdy.
Exactly.
So here was one that got a hint from earlier.
Yeah, Connor gave this away earlier, but really cool, again, utilization of the space up there, right? They have to have the enclosure up there anyway, so why not skin it with a section marker and help out the fans know where they're going. So this one is at a large zoo in Southern California. Kind of a vanilla one, but again, blends in pretty good.
And the reason why I always like to pull up this one to show people is that even a simple just skinning it to match the background is pretty easy to make it blend in more, not be as appealing or appalling to the eye. So even a simple job can make it pretty easy.
That's a good
I also asked someone if it's painted. No, so these are actually skinned.
Yeah.
So if you imagine like how you wrap a vinyl car, it's very similar to that process.
Yeah, that's what I was just gonna mention, because you wouldn't want to paint your antennas or your access points. You want to use a particular type of skin so it doesn't cause any issues. So good thing to point out there for sure. And yeah, so simple, but yet you can see it's so effective, making it blend in a lot there.
Yeah, and another point on that, Matt, I know you mentioned the paint. Obviously, you don't want to do that for a few reasons. One of them being voiding the warranty on the access point or the antenna. With the vinyl skin, you can just peel it right off and execute on that if you need to.
Mm-hmm.
Great point.
So here's another one. It's a little smaller, but we'll see if y'all see it.
Yep, let us know in the chat if you can see the antenna.
So this one actually we made the antenna black, so we built it with black resin. So it's not actually skinned. This one we have an option to change the colors with the resin. So we actually manufacture these in black. Have a lot of different options there with our mounts as well to make it all blend in. And just even if it's not blending in, like this one's not blending into the background, but it's part of the overall aesthetic.
Yeah, they
so it
had their
doesn't draw
black
any light to it.
trimmings and it fits in.
Oh, well, you done a good job, because there was people in the chat saying they thought it was actually.
Yeah, I've seen a lot of different aces that threw people off. Yeah, that was good.
So guys, question. So, in reading some of the questions and some of the chats, it sounds like, a lot of people weren't aware that there are aesthetic skin options that are offered out there. And also from a environmental considerations for outdoor APs, NEMA enclosures, but also physical security for APs that might be in gyms and such. Can you kind of speak on briefly on some of your offerings around that, just for awareness to some of our audience?
Sure. Yeah, I can do that. So as you mentioned, there's a couple different options, right? You can skin stuff to blend it into the background, which does offer a little security because people don't know that it's there. We've got, some rounded enclosures that we can either skin or people can paint that you can put on the sides of buildings, bollards that can go in planters, or, around walkways. We see that a lot at university campuses and around pool areas and things like that. Again, just very typical NEMA enclosures where you can kind of lock it to secure it a little bit. So a lot of different options there. Certainly from an aesthetic standpoint, I would say our vinyl skins, the bollards, and some of our rounded or custom enclosures, as you saw in the basketball arena, are very popular.
Thank you.
Yeah, another question here from the Q&A. In a large classroom setting with multiple access points, what would you suggest for antennas so that airtime utilization is spread amongst all the APs, omnis or directional access points for the ceiling mounts?
That depends more on the individual classroom. If it's like a college classroom where you have a large structured like lecture hall kind of area, it's typically better to use kind of like how we were seeing in the stadium, more of those 60 by 60 degrees antennas to make the nice isolated cells. Those have such a quick drop off from the 3dB that they're not going to have the bleed over. So it's going to evenly distribute your clients in the sections that they're in to really make the most efficiency out of the airtime utilization between all those APs. So it depends on the classroom. If you're talking about a college lecture hall, if you start getting into more of a high school structure, typically those aren't going to have multiple, but if you do, you can use omnis at the lower ceilings and turn down the power levels, and that works fairly well most of the time.
And then another that we have, which by the way, we do now offer a private 5G planning tool. But this is centered around Wi-Fi design environments. But we know that private 5G, private cellular is emerging technology. A question that's been asked that seems kind of be popular amongst our audience is, are you all in the business of also creating antennas for those type of use cases, or is that something maybe coming down the line?
Yeah, no, we have a lot of products that actually are 5G capable, as well as CBRS. We have directionals, omnidirectionals. Our lineup isn't as diverse as our Wi-Fi is, but we do have multiple in each category. So we do have a fairly rounded lineup that's used extensively by a few outdoor supply companies.
Perfect. Thanks, Connor.
I see some questions asked around the types of cables that you can use between the access point and the antenna. And is there any concerns on the length of the cable that you have between the access point and the antenna? Does that have any effect? Or maybe you can just tell everyone a little bit about that.
Yeah, so a cable obviously has a significant impact on the actual performance of the antenna. Partially because as you start using longer cable runs, just naturally you're going to attenuate more throughout that cable. And that's going to vary depending on, one, the length that you're going, two, what size cable. So we have ATS cable, for instance, it's an LMR equivalent. They basically have the same electrical properties, but there's 100, 195, 200. And as you go higher and higher, you get thicker and thicker cable. And those are better since they're a lower loss cable, especially at the higher frequencies. And then again, the last thing you need to consider is what frequencies are you concerned about? You're going to have less loss over longer distances on 2.4 than you are on 5 and 6 gigahertz, because the higher frequencies are going to have a much higher attenuation throughout that cable. Our antenna specifically, when we show our specs for them, that's showing you the gains at that connector. So if it says it's a 13 dBi antenna, it's 13 dBi at that connection point. Now you'll start adding extensions to say run the antenna 15 feet away. Well, now you need to take into account the gain loss you're going to have in that cable in that 15 feet to run the AP. So it's a pretty significant consideration, especially if you're using lower gauge cable. If you use ATS 100 over 10 feet, you're probably going to lose 5 dB of your gain.
There's some really good cable loss calculators out there that you can Google too, where you can pick the type of cable, the length, and then the frequency, obviously, that you want to do the math on. So there's some really good ones out there if you Google it. I use them all the time.
Great. And then thank you guys for both answering that. There's another upvoted question in the Q&A from Adrian asking, saying that I design for factory and warehouses. One of my issues I run into is housing access points in environments like slurry, where it's slurry. I don't know. Is that a US term? I have to guess in a cold environment where it's refrigerated, and or the need to wash the area down. What kinds of enclosures do you suggest, and do you guys have any enclosures that would be good for these environments?
Yeah, we work in a lot of those different environments. So a couple of things you can do. So for a freezer, for example, you can either try to house the AP outside of the freezer and put the antenna inside, which typically can do the job. If you need the AP inside of a freezer type area, we have heated and cooled options, so temperature controlled options inside of a NEMA box, which will also allow it to be sprayed down and things like that, depending on the chemical. I mean, if you're spraying it down with some really harsh chemical, you might have to look at different options. And then again, in some of the, like a slurry plant or something like that, you would want to go with some sort of NEMA rated enclosure to protect the AP. They're RF transparent. The ones that we have anyway are RF transparent, so you won't see any loss or anything like that from the signal. So we have a lot of different options for all the different harsh environments.
And then another popular question we seem to have is around outdoors, truck parking lots specifically in this case. What are some of the options you have for coverage around that? I know each lot's going to be different types of requirements, but a few options that you do have in those type of situations.
So that I guess we're asking about for the truckers themselves and their cabs, or is it for the unloading, offloading?
It didn't specify, but I suppose in both cases, perhaps.
Yeah, we'll go through both. So that is a very common one that we see come up. Obviously, getting signal into the trailers themselves, if you're trying to get signal to inventory or register items that are in that trailer, is difficult to go through the trailer itself because it's just a big metal box. And same with the cab, it's just a big metal box with thick glass. So what we've seen a lot of success with is either having an antenna as a bollard at the entrance, shooting RF into the trailer itself. So it's a little bit more protected in that bollard. If they do back up to it, depending on how close it is and how much room they have to hit it, it'll protect it a little bit more. But it gives you signal into the actual trailer without having to go through the exterior. So there's been good success on that. We've had a few deployments where we mounted on the outside and try to shoot it through the trailer. That does work. It's not as effective overall. And then for the cab itself, if you're looking for to have the drivers be able to register, hey, I docked at this time, I'm being loaded here, and then I'm taking a break now. A lot of times it'll be a near light post, and we actually have a lot of enclosures that are easily mounted to light posts. They can actually tap in to the power of the light post if you want to do a UTP system or even a solar system on those light posts and have a cradle point backup so you don't have to run any data to it. And then having a directional antenna on that shoots towards the cabs. We've seen some good success with that.
Yeah, another option I'll throw out there, we work with some large logistics companies. So if you're far enough back and you can imagine, 10 trucks lined up, people will take our warehouse antenna and flip it on its side. So you get a really thin area of coverage, but it's blasting across the entire row of trucks and getting in there enough. So we've seen some pretty creative designs with our antennas.
Mm-hmm.
Nice. And another popular one that seems to be around what was mentioned earlier during this presentation, outdoor 6 gigahertz ready or capable antennas. Can you speak a little bit about those?
Yes. So specifically for the ones that we showed earlier, that actually falls under LPI rules. So Juniper Mist came out with the AP45E worldwide, and we worked with them to develop that connector we mentioned on the connector slide, and utilizing that as well as a plate cover, and then making that antenna now an integrated part of the system. we were able to use external antennas with 6 gigahertz under the LPI rules. So that being said, obviously you have to use it indoors. That's part of the LPI regulations. In the US, that isn't allowed right now. It wasn't approved for the US. They are shipping the AP45E as a 245 model, with the possibility of 6 gigahertz being enabled under LPI when standard power is released. So that is a possibility in the future for the ones that we specifically showed here. And then working with the actual standard power that's going to come out hopefully later this year. We actually already have a few antennas lined up for other manufacturers, Cisco with the 9167, that when that time comes and standard power is approved and we have AFC figured out, we'll be ready to be able to use 6 gigahertz outdoors. So that it's not here yet, but we are on the prepared path for it. Just waiting for the final approval from the government, basically.
Awesome.
Well,
Thanks.
thank you so much for that, everyone. Since we've just crossed over the top of the hour and we took lots of great questions from everybody in the audience, we can wrap the webinar up here. So thank you, everyone, for staying on with us. And I just want to say a huge thank you to both Connor and Jason from joining us from AccelTex today. I think everyone in the chat can agree with me. This was a fantastic webinar, lots of great content. Hopefully you feel a bit more comfortable and confident to use external antennas in your designs moving forward. A huge thank you to Dale and Stu and the rest of the Ekahau marketing team for putting this together, but a big massive thank you for everyone yourself for joining us on this webinar. We love doing these and we love having you here with us. So we will look forward to seeing you on the next one. And I just did see someone mention about the Arsenal game tonight in the chat as well, so they obviously know I'm an Arsenal fan. So yeah, thank you guys so much for being here. This was a really great webinar today.
You bet. Thank you guys. Appreciate
you all.
you having us.
Thank you, everyone.